Good morning, all. Today we deal important concepts, basic concepts. You take one system. Okay, suppose water. How many moles? How many molecules? How many atoms? Okay, how many moles? How many molecules? How many atoms are there? Okay. Mole means in SI system amount of substance is expressed in moles. It is equal to Avogadro number of chemical units. It is equal to gram molar volume. It is 22.4 liters at STP. Okay. It is equal to gram atomic mass of metals equal to gram atomic mass of inert gases, gram molar mass of di or polyatomic species. It is nothing but mole. In SI system, the amount of substance is expressed in moles. It is Avogadro's number. Gram molar volume, gram atomic mass of metals. Mostly elements are metals. Okay, S block elements, D block elements, F block elements are metals. Gram atomic mass of inert gases, gram atomic mass of di or polyatomic substance H2O3, P4, H2O, etc. Di or polyatomic. Okay, di or polyatomic substances. Mole means just equal to Avogadro number, gram molar volume, gram atomic mass, gram atomic mass of inert gas, gram molar mass of di or polyatomic substance. Okay. It is mole. Molecules. Atoms combine to form molecule. Okay. Two or more atoms combine to form molecule. There is chemical bond. How many molecules? Number of molecules is equal to small n into capital N. Small n is number of moles. Okay. Number of atoms. How to find number of atoms? It is equal to small n into capital N into atomicity. Okay, number of moles into atomicity. S8, what is atomicity 8? O3, atomicity 3. Glucose, what is atomicity? 6 plus 6 plus 12, 24 is atomicity. H2SO4, 2 plus 4 plus 1, 7 is atomicity. Okay. How to find number of atoms? Small n into capital N into atomicity is number of molecules into atomicity. So, number of atoms. Suppose 18 grams of glucose. First question, number of moles. How many moles are present? Weight by molar mass, 0.1. Second one, number of molecules. Small n into capital N. Small n is 0. Here 18 by 180 into Avogadro's number. It is equal to 6.02 into 10 to the power of 22. Number of atoms. How to find number of atoms? It is equal to small n into capital N into atomicity. Atomicity means number of atoms per molecule. Small n, capital N into atomicity glucose 6 plus 12, 24. Okay, 24 into this, work out, you get answer. So number of molecules, number of atoms, number of moles. It is important area. Small n into capital N into atomicity. Okay. You can convert volume into moles. For example, 11.2 cubic decimeters of SO2 gas at STP. Question is how many moles? How many moles? 22.4 liters is 1 mole. 11.2 liters. How many moles? 1 liter is cubic decimeter. 11.2 into 1 by 22.4. Here 1 by 2, 0.5 moles. You can convert volume into moles. Next one, number of molecules into moles. For example, you take 6 into 10 to the power of 20 molecules of hydrogen gas. 6 into 10 to the power of 10 molecules of hydrogen gas. Hydrogen gas. Now Avogadro number is equal to how much? Approximately 6 into 10 to the power of 23 is 1 mole. 6 into 10 to the power of 20, how many moles? You cross multiply this, you get 10 to the power of minus 3. Answer is 10 to the power of minus 3. So anything, mass to moles, volume to moles, number of molecules to moles. That in stoichiometry we study this. Okay. 10 ml of decimolar solution of urea. 10 ml of decimolar solution of urea. Okay. Solution of urea. How many moles? Do you know molarity? Number of moles per liter. This formula, we are finding number of moles. N is equal to M into capital M into V by 1000. So M is decimolar. What is deci? 0.1. Deci 0.1 into 10 ml by 1000. You get 10 to the power of minus 3 moles. Okay. They are asking how many moles. Molarity is number of moles per liter. N is M into V by 1000. N is 10 to the power of minus 3 moles. Okay. We can convert molarity into moles. Okay. It is mole concept. Second one, oxidation state. Charge carried by one atom. Charge means real or imaginary charge. In ionic compound, charge is real, covalent compound, charge is imaginary. Okay. Charge carried by one atom. In combined state, in compounds, that is oxidation state. Okay. So certain empirical rules are followed. First one, rule 1. In free state, oxidation number of element is 0. 0. Free state means one kind of atoms. Suppose 24 karat gold, free state, gold. Next one, silver, ozone 0, rhombic or plastic sulfur 0, white phosphorus 0. In free state means one kind of atoms. One kind of atoms it is 0. Rule 2. In compounds, first group elements. We know first group lithium, sodium, potassium, rubidium, cesium, francium. First group elements show +1. Second group elements show +2. Fluorine shows -1. Fluorine shows -1. Universal. In any compound, first group +1, second group +2, fluorine -1. Okay. Oxygen mostly show -2. Mostly show -2. Okay. Hydrogen mostly show +1. Hydrogen mostly show +1. These points you have to remember. In free state, oxidation number of any element is 0. In combined state, compounds means combined state. Simple compounds or complex compounds. First A group show +1, second group show +2, fluorine shows -1, oxygen mostly show -2, hydrogen mostly show +1. These points you have to remember. Third rule, in amalgams, metal plus mercury is amalgams. Metal mercury combination. Oxidation state is 0. It is not a compound. Amalgam is not a compound. Try to understand. Oxidation state is 0. In metal carbonyls, metal that you study in D block, metal carbonyls, metal show 0. Metal show 0 oxidation state. Last one, algebraic sum of oxidation states of all elements equal to charge, equals to total charge. These points you have to keep in the mind. Okay? These 5 rules are mandatory. You should remember this. In examination they give this, like, what is the oxidation state of chromium? We have 3 types of elements: potassium, chromium, oxygen. Alkali metal +1, chromium X, oxygen -2. Okay? 2 into +1 +2, 2 into X 2X, -14 is 0, X is equal to +6. So we have we have to practice n number of examples. Okay, MnO4. What is the name? Potassium permanganate. Here how many elements? 3 elements. Potassium, manganese, oxygen. +1 + X, 4 into -2. -8 is 0. On oxygen -2, 4 oxygens. 4 multiplied by -2. X is equal to +7. Okay. You need to take examples to practice. Let us take ions. Sulfate ion, for example. What is the oxidation number of sulfur? It is X. How many oxygens? 4. 4 into -2 plus 4 into -2. What is the net charge? -2. X is equal to +6. Similarly, ammonium ion, NH4 plus. What is the oxidation state of nitrogen? X. Hydrogen shows mostly +1. 4 into +1 plus 4 is equal to +1. X is equal to -3. Okay. It is important one in redox reactions also, oxidation state. Some exceptions are there. What are exceptions? In peroxides, peroxy bond is there. Oxygen shows -1. For example, sodium peroxide, hydrogen peroxide, barium peroxide. Here oxygen show -1. Peroxy bond is present. Peroxy bond, over single bond is called peroxy bond. Oxygens are connected by single bond, peroxy bond. Next one, in superoxides. Superoxides, oxygen show -1/2. For example, KO2, potassium superoxide. It can show -1/2. Then peroxides and oxides are different. Okay? Peroxides, superoxides are different. For example, CrO5. What is the oxidation state of chromium? If you apply the rules, you get wrong answer. Chromium, what is the maximum oxidation state of chromium? Tell me. It is +6. But your answer is +10. So this is wrong answer. So then in this case you have to draw the structure. OO bond is peroxy bond, -1, -1, -1, -1, -2, X minus 6 is 0, X is equal to +6. Okay, whenever peroxy bonds are present, your electronic configuration is also important. Chromium D5S1. From this, what is the maximum oxidation state of chromium? +6. You don't get +10. +7 is wrong, +8 is wrong, +9 is also wrong. Because maximum oxidation state is +5. Sorry, +6. You don't get +7, +8, +9. You have only 6 rupees. How do you lose 7 rupees or 8 rupees? That's why maximum is +6. Okay. Some Br3O8 is given, NCERT example. Here also you need to draw the structure. Okay. Oxygen maximum, bromine maximally form 7 bonds. Terminal bromines, -6, -2, -2, -2, X minus 6 is 0, X is equal to +6. Middle bromine, non-terminal bromine, +4. Here -2, -2, -2, +6. So oxidation state of bromine is +6, +4, +6. You need to work out various examples. Third case, limiting reagent. What is limiting reagent? Okay, A plus B gives products. Suppose 3C. Okay, AB are reactant, C is product. They react as per equation and you mix as per equation, no limiting reagent. One practical problem, sometimes they don't react as per equation. Conditions are there. You don't mix as per equation. Suppose 2:3. Suppose 2 moles of A, example 1, 4 moles of B are mixed. Okay, equation is not followed. 2:3 is followed. But here 2:4 is, they are mixed in 2:4 ratio. So there is limiting reagent. In this case, there is limiting reagent. Second case, 3 moles of A, 2 moles of B. Tell me, 2:3 you have to mix, but 3:2, this is okay. Third case, 0.5 moles of A, 0.6 moles of B. Okay, it is also, there is limiting reagent. The equation is not followed. Okay, equation is not followed. 2:3 ratio you have to mix. It is not 2:3 ratio. What is the ratio? It is 0.5 into 0.6. Approximately 1:1.1. So there is limiting reagent. So what is the limit? How to find the limiting reagent? Given moles by equation moles. Given moles by equation moles. Stoichiometric moles. I am taking first case. Given moles 2 moles. Equation moles 2 moles. Okay. Given moles 3 moles, given moles 4 moles, equation moles, it is A, it is B. Given moles by equation moles, which is the least one here, it is limiting reagent. It is the short way. Given by equation, least one is the limiting reagent. Given by equation, I am taking this, given by equation. Okay, which is the least, it is limiting reagent. Okay, the simple way to find limiting reagent. Next I take this 0.6 moles of A plus 0.9 moles of B, 0.12 moles. So I tell you a simple thing, given moles by equation mole, given moles by equation moles, given moles by equation moles, which is the least, it is the least, it is the limiting reagent. It is the simple way to find. Given moles by equation moles, least is the limiting reagent. It is completely consumed in the reaction. Here, limiting reagent completely disappears. Completely disappears. Decide the amount of product. Decide the amount of product. Okay, this is one way to find limiting reagent. Stoichiometry is not followed, then we have limiting reagent. When you don't follow stoichiometry or they don't react as per equation, they means reactant, there is limiting reagent. Simplest way, given by equation moles. It completely consumed in the reaction, it decides the amount of product, that is called limiting reagent. I take this, for example, N2 plus 3H2 gives 2 ammonia, it is given. Just I am finding limiting reagent here, 2 moles of nitrogen, okay, 4 moles of hydrogen are mixed. 2 moles of nitrogen, 4 moles of hydrogen are mixed. What is the limiting reagent? Okay, given moles by equation mole. Equation 1 mole. Given moles by equation moles. Given moles for equation moles 3. So it is the limiting reagent. Least is the limiting reagent. Least value is limiting reagent. So hydrogen is limiting reagent. Given moles by equation moles. This one you have to do in the rough. Okay, you have decided this limiting reagent is hydrogen. Okay, you get 50% of the answer. Okay, I take this 4NH3 plus 5O2, 4NO plus 6H2O. Take this equation. Okay, suppose 2 moles of ammonia is mixed with 3 moles of oxygen. What is the limiting reagent? Given moles by equation moles, 2 by 4, 1 by 2, 0.5. Oxygen, given moles by equation moles, it is equation moles. Yeah, 0.6, which is the least. 0.5 is the least value, it is the limiting reagent given by equation. Okay, it is the simplest way to find limiting reagent. Okay, so I stop now. I explain the remaining part in the next video. Thank you, one and all. మంచి చేసిన
అండి